This video covers solving limits involving infinity using an algebraic approach. Before we do an example, let's review a quick definition that will be important to algebraically solving limits involving infinity. If n is a positive integer, then these limits will equal 0.
Why is this true?
I think about it like this. If we are trying to evaluate the limit as x approaches infinity of 1 over x squared, the answer would be 0 because 1 divided by a very, very large number, which is squared, will provide an extremely small decimal that would essentially be 0.
Okay, that makes sense.
Great! So let's apply this concept in an example. Let's evaluate this limit. To solve this algebraically, we first need to do some preliminary algebra so that we can get to a point that we can examine their ratio. We need to divide the numerator and the denominator by the highest power of x that occurs in the denominator. Doing so will allow us to use the limit definition we just learned. In this case, the highest power is x squared. So we will divide the numerator and denominator by x squared. Now, let's distribute to each term. Now we can simplify. Now we can use the limit laws that you learned in the Topic 1 video, Finding a Limit Using an Algebraic Approach Part 1, to solve this. Here is the list that we went over in that video. First, we can use the quotient law of limits. Next, we use the sum and difference laws shown in 1 and 2. Last, we'll use the third law. We can now finally use the rule we used at the beginning of the video. Can you evaluate each of these limits?
The limit of a constant is just that constant, so first limits on the numerator and denominator will equal 3 and 5 respectively.
Excellent work! What about the remaining limits?
Applying what I learned earlier, I believe the rest are going to equal 0 because I divided by a very large number, which is essentially 0.
That's correct. So, what we get now is 3 minus 0 plus 0 divided by 5 plus 0 minus 0, which is equal to 3/5, which is our final answer.